Welcome friends. In this video we are going to look at the science paper 2 where we are going to make now the final part of our prediction and random questions. Now let's look at the first question here. What do you understand by each of the following? So we have the first one, an anhydrous salt. Now before we look at the anhydrous salt, we may look at the hydrated salt. So what do you understand by the term hydrated salt? So the word hydrated has to do with water. So if we look at hydrated salt, we are looking at the type of salt or a crystal that has trapped water molecules inside its structure. For example, we may have silicon chloride. Hydrated silicon chloride. We have hydrated silicon chloride. We have copper, hydrated copper 2 sulfate. We have hydrated cobalt 2 chloride. All these are examples of the hydrated salt. Now, what happens if this salt or these salts molecules were to be heated? So if they were to be heated, the water that is trapped, which is called water of hydration, can evaporate. So now, if that water is evaporated, what do we call that salt? So that salt now is now called anhydrous salt. So the anhydrous salt is just the opposite of hydrated. In hydrated salt there is water. In anhydrous salt there is no water. So we can say is a crystal. Is a crystal? So we say is a crystal that does not contain water molecule. Then Roman number 2, we want to look at now an efflorescent substance. So what are efflorescent substance? We are looking at substance that can lose its water of crystallization through evaporation to the air. So say is a substance that, so say substance that can lose its water. Its water of crystallization to the air or to the surrounding. Then give an example of the following. The first one, an efflorescent substance. So what do you think what substance can we consider to be an efflorescent? So we can look at the hydrated copper 2 sulfate. Then if you look at the delicescent substance, a delicescent substance is just a substance that can absorb so much moisture from the atmosphere and that it dissolves in the absorbed water. So after it absorbs water, then this substance may dissolve. So it's what we call a delicescent. And the best example that we can give under delicescent, we can look at calcium chloride. So let's just look at calcium chloride. Okay, so let's also look at the other question. So the other question, bodium BO is a newly discovered element. It is a solid at room temperature and pressure. It can be cut with a knife. So the first characteristic, it can be cut with a knife, okay? Reacts vigorously with water, liberating a flammable gas and forming a solution with a high pH. So high pH, we are looking at a solution that is a basic. Then A1 we have this question: to which group of the periodic table does bodium belong? So this is group 1. So group 1 have these characteristics that we've mentioned. They are soft, that they can be cut with a knife. Then write a balanced chemical equation for the reaction between bodium with water. So let's look at bodium. We have been given the symbol BO. So this will be a solid plus water. So whenever a reactive metal such as a group 1 reacts with water, we get a metal hydroxide. So in our case, we are going to have bodium hydroxide. Now, if you look at the valence number for group 1, they have the valence number of 1. Hydroxide has a valence number of also 1. So the chemical equation, chemical formula will be BO hydroxide plus hydrogen will be also produced. Then let's do this. So we put 2 here so that we have 2 bodium. Also 2 here, we have 2 bodium. So 2 bodium is balanced. Now let's look at hydrogen. So hydrogen here, from the bodium hydroxide, there are 2 plus this 4. So we can just put a 2 here so that we say 2 times 2. We have 4 plus this one, oxygen. We have 2. Then state whether you would expect your bodium carbonate to decompose on heating. Give a reason for your answer. So bodium carbonate cannot decompose, and if they were to decompose, they can only decompose partially. Why? Because group 1 elements are stable when it comes to carbonate, so they are stable. So because the group 1 elements, the group 1 carbonates are stable to heating. Okay, so that is what you have to look at if you look at the carbonates of group 1. So they do not decompose no matter how you heat. Though some nitrates may decompose, and that decomposition is just partially. So we'll move on to a question that has to do with the preparation and collection of a certain gas. So the diagram below shows the setup of the apparatus that will be used to prepare gas X. Then we can look at the hydrogen peroxide, then manganese oxide, then identify a gas X. So the question is just indirectly asking us that which gas is or can be prepared from decomposition of hydrogen peroxide. So just know that the gas that can be produced by this is oxygen. So that is our answer here. Then describe the chemical identity test for gas X. So gas X, we are saying this is oxygen. So we say it relights a glowing splint. Then B1, what is the purpose of adding manganese 4 oxide to the hydrogen peroxide? So to speed up the rate of chemical reaction. So say to speed up the rate of chemical reaction. So it is working as a catalyst. Then explain why this gas is obtained using the method shown in the diagram above. So obtaining same as the collection. So if you look at this collection, we have water here. So this one is what we call displacement of water. So the gas will pass through this water, then will move up here. So the first thing that you need to know about the collection of gases, how do you know that this gas will be collected by this method? You just have to look at the two factors. The first one, solubility. So if the gas is soluble and insoluble, then it will help you to identify the method that you can use. Then after solubility, you also have to look at the density. Is this gas denser than air or less denser than air? So density has to do with the comparison between the actual gas and the air. Now, whenever you see water, the gas that can be collected by displacement of water is a gas that is insoluble or slightly soluble, because we cannot use a gas that is able to dissolve in water, because if oxygen dissolves in water, it will not reach where this gas X is, so it won't, as the result it will dissolve. So for us to use anything to do with water, we have to look at the solubility. So the first one is that the displacement of water is suitable when the gas is insoluble or slightly soluble. For example, carbon dioxide, there is also, if you look at hydrogen and also oxygen, all these can be used by displacement. So we'll say because oxygen is insoluble in water. Okay, so now we move on to questions that involves extraction of metals. Here we have extraction of copper. So one measure of copper is copper pyrite, which is this one. To extract copper from the ore is crushed, then undergoes froth, flotation, and finally roasted in the air. The metal is then purified by electrolysis. Explain why. Roman number 1, the copper ore has to undergo froth, flotation. So maybe let's see if we can have a picture here. So let's say we have, this is where this froth flotation is taking place. So what they do is they will put the ore under this ore. There are impurities like sand, or maybe we can just say soil particles. Then this should be something like a detergent. So now what happens is whenever the ore is, the first one, the ore is concentrated using the method of froth flotation. Then after that, the charcoal pyrite particles will float, will go here on top. So will float on top to the top of the tank and collected, while most of the other unwanted minerals sink to the bottom. So this is what we call froth flotation. So the importance of this is to separate the copper ore from unwanted substances such as sand. Then number 2, the copper ore is roasted in air. So if you look at the roasting in air, it's the reaction between copper sulfide with oxygen. So what is the importance of that? To remove sulfur. Then B, write a balanced chemical equation for the reaction that occurs when the copper ore is roasted. So this reaction is have solid plus oxygen, a gas, going to have copper plus sulfur dioxide. So now let's check if our equation is balanced. So copper 2, so we need 2 here. Then after that, let's look at oxygen. We have 2, also 2 here. So our equation is now balanced. So this is the equation that summarizes the roasting of copper ore in air. Then we go to question C. The physical properties of copper can be explained in terms of metallic bonding. Describe with the aid of a label diagram the metallic bonding in copper. So the metallic bonding is like this. So here we are going to have protons, electrons, protons, electrons. So this is what we call the metallic bonding. So under metallic bonding, the positive, this positive, we'll call them casualties. We are told a label diagram. Then the electrons will be called C of electrons. And at this point, we are saying the electrons, they become delocalized. Then in terms of the force of attraction, the force of attraction that happens between cations and the sea of electrons is that force of attraction due to the opposite charges. Then explain how metallic bonding makes copper to be malleable. So the word malleable simply means to be hammered into something new and into a new shape. So say this is because the positive ions are able to slide over each other. Without breaking. So that is the point here. Then D, state one use of copper. Copper is used to make electrical cables. If the question comes, why? Because it is a good conductor of electricity. Okay, so let's also answer this question. Now this question has to do with the preparation of nitric. So we are told nitric acid is an important acid in everyday life. Name the commercial process used to prepare nitric acid. So this process is known as the Oswald process. So we have the Oswald process. So Oswald process is just like the way we look at the Haber process, which is the process by which ammonia is produced on a large scale. Now B, state the catalyst used during the commercial preparation of nitric acid. So here we call this one as the platinum rhodium. So this is the catalyst that we use. And remember, this Oswald process is in 3 stages. And the need of Oswald, platinum rhodium, is in stage 1. Then C, the equation below shows the initial stage in the industrial preparation of nitric acid. Okay, copy and balance the equation. So the initial is just the first stage. So copy and the balance. So the importance of this stage, it is just to produce the nitrogen monoxide. So that is the importance. So let's look at how can we balance it, this equation. So we have 1 nitrogen, 1, 3, 2 hydrogen, oxygen. So let's begin by, let's put a 4 here. So we put a 4 atoms of nitrogen. Also we put a 4 here, 4 atoms of nitrogen. Now if we put 4 in front of ammonia, we are going to have, this will give us 4 times 3, 6, 4 times 3, 12 atoms of hydrogen. So we need a 6 here so that we have 12 atoms of hydrogen also. Now let's look at the atoms of oxygen on the products part. So from the nitrogen monoxide we have 4, since there is a 4 here. Then here we have 6, which is the total is 10. So since it's 10, we just have to put a 5 in front, because 2 into 10 will give us 5. So that is what we are supposed to do for this question. So we have balanced the equation. Then D, the nitrogen monoxide produced as shown by the equation in C above react with oxygen to give nitrogen dioxide. Construct the balance chemical equation. Okay, 5 should be like this. So construct the balance chemical equation. So this is stage 1. So the importance of stage 1, if asked, it is just to produce the nitrogen monoxide from ammonia. Then for stage 2, so stage 2, we want to react the nitrogen monoxide, which is a gas, plus oxygen. Then this will give us nitrogen dioxide. So nitrogen dioxide, we need to have a 2 here. Di means 2, mono 1. So how can we balance the equation? So we can put 2 here and also 2 here, 2 nitrogen, 2 nitrogen. Then on the reactant side, we can see that we have 4 atoms of oxygen in total. 2 times 2, 4. So our equation is now balanced. Then how is nitrogen dioxide converted to nitric acid in this process? So the final now stage, which is stage 3, how can we convert nitrogen dioxide? So by just dissolving it in water. So by then F, explain why the concentration of nitric acid cannot be made more than 68% even if it is distilled. So why can't we make maybe at least 70-80% of nitric acid even if it's still distilled? So we'll say not all the nitrogen dioxide dissolves in water. So only a certain percentage would dissolve, thus this 68%. Now explain why the higher concentration of nitric acid can only be obtained if it is mixed with concentrated sulfuric acid and redistilled. So explain why the higher. So now we'll say concentrated sulfuric acid will now force or make these now at least a greater percentage to react. So we can say to speed up. So in this way we are looking at like as a catalyst, so to speed up the production of nitric acid. Then gave N2 uses of nitric acid. So uses of nitric acid, they can be used to make fertilizers, then also explosives, also to make TNT. Okay, so we have B5V, chlorine, bromine, and iodine are elements in group 7 of the periodic table. A1, describe the change in the states of elements at room temperature and pressure as the atomic numbers increases. So here, this is same as if you look at the periodic table, you will be able to see that these are in group 7, and the one on top is fluorine. Then after fluorine we have chlorine, we have bromine, then we have iodine. Now if we move from the top going down here, their atomic number increases, because if you look at the atomic number of fluorine is 9, for chlorine is 17, then for bromine is 35, then for iodine has 53. Now if you look at the reactivity series for group 7, as you go up the group, their reactivity increases. Now we are not looking at the reactivities for now, we are just looking at what happens to the change in terms of sets of elements at RTP. So if the atomic number increases, the states of matter will change from gas to liquid to solid. Because if you look at the fluorine and the chlorine, these are gases. Then bromine is a liquid, then iodine is a solid. Then remember, why is chlorine used in water treatment? Because chlorine is a poisonous gas. Then write an ionic equation for the reaction between chlorine and aqueous potassium bromide. So let's look at this. So we have potassium K, bromide we have Br. So this is the aqueous reacting with chlorine. Now the first question that we are going to ask ourselves is, will this reaction occur? So for us to tell or to see if this reaction will occur, we need to look at which one is more reactive. So if you look at the arrangement of these elements, chlorine is above bromine, so chlorine is more reactive than bromine, so it will take the position of bromine. This will give us potassium chloride, which is aqueous, plus bromine, which is a liquid. So this is what we call a single displacement, where one element is displaced by another element. So we have a balance. Now the question is ionic. So what are we going to do? We need to look at the ones in aqueous phase. So potassium bromide is in aqueous, so potassium will form a positive one because it's from group 1. bromide will form a -1. This 2 is the number in front, the number that we use for balancing. Then for the compound that is in gas, solid or liquid, cannot be broken into ions. Then potassium here plus. Then here we need to look at the spectator ions. So the spectator ions are those in the same state, which is we only have potassium, yes. Then our net ionic equation will be this one. Okay, so now we have another question. A solution of aqueous sodium hydroxide was added from a burette to 25.0 cubic centimeters of dilute sulfuric acid solution in a conical flask. The pH of the mixture was measured during the addition of sodium hydroxide. So let's look at the reactant. So sodium hydroxide is a base, and it's a strong base because of sodium, which is in group 1. Then sulfuric acid is also a mineral acid, which is a very strong acid. So we are looking at the reaction between a strong base and a strong acid. So before the addition of aqueous sodium hydroxide, what was in the conical flask was acid. So the pH was showing the acid. Now after the addition of a strong base, the pH started to change from the acidic to a neutral, because we are looking at a neutralization reaction. How do we know that this is a neutralization reaction? Because we have a base that is strong and an acid that is also strong. So say the pH changed from acidic medium to a neutral solution. Then name the type of reaction that took place between sodium hydroxide and sulfate. Since these two are strong, this is what we call neutralization. So neutralization reaction, where the products that are produced are neutral. Write a balanced chemical equation for the reaction above. Okay, so we have sodium hydroxide is this one, sulfuric acid is this one, aqueous. Remember, an acid is in aqueous phase, then sodium hydroxide is also in aqueous phase. So sodium will react with sulfate, giving us sodium. Sodium has a valence of 1. Sulfate has a valence of 2. It's a radical. So the 2 from the sulfate will come here. Then we write our sulfate 4 plus water. Remember, the product is salt and water. So whenever you react a strong base and a strong acid, the product will be salt and water. So what you do, so what we are supposed to do here, we just put 2 here, so that we have 2 sodium, 2 sodium. Then hydrogen becomes 4, because in sodium hydroxide we have 1 plus another 1. This is same as let's say x plus x is equal to 2x. So sodium hydroxide plus sodium hydroxide is equal to 2 sodium hydroxide. So in 1 sodium there is 1 hydrogen, and also, so in total we have 2. That's what we mean. So 2 plus 2, 4. So we need to put a 2 here. So from there, we can see that our equation is now balanced. Sulfuric acid is a strong acid. What does this mean? It ionizes completely in water. So that's what it means by strong acids. They ionizes completely in water. Okay, so iron 2 sulfate crystals can be prepared from the reaction between iron metal and a warm dilute sulfuric acid. Then A1, construct a balanced chemical equation for the above chemical reaction. So we know it's a it's a reaction between a metal and an acid where we are going to have salt plus hydrogen gas. So say iron, which is Fe, plus sulfuric acid dilute, sulfuric acid aqueous. Then we are told we are going to have iron 2. So whenever we have this number 2 here, it simply means that it's a valency that we are going to use. So iron has a valence of 2, sulfate has a valence of 2. So since these two numbers are even, we can just cancel them, giving us this final equation plus hydrogen gas. And for this one, the equation is balanced. Then what is the importance of warming the acid? So we can say to initiate the chemical reaction so that the reaction can start. So to initiate the chemical reaction and speeds it up. So here the homing is like there are two importances that we can draw from here. The first one, it is acting as an initiator. So initiator where it is the starter, so providing the energy that is required to start. Then the second one also to speed up, so as a catalyst. Then how do you ensure that the iron 2 sulfate obtained is free of sulfuric acid? So we don't want the salt to be acidic, we want the salt to be neutral. So how can we get rid of the acid? So how do you do that? So make sure that the iron metal should be in excess. Why do we need the iron in excess? So that all the acids will be used. It's easier to remove the iron or the metal than acid. If the salt is found to be acidic, it's now hard to remove that acidity. But after you've done this reaction and you found the metal to have excess metals, there is a certain percentage of metal that is not reacted. You can just move metals by filtering. So whenever you want to get rid of all the acidic, make sure you use the metal should be in excess. Then describe how you can obtain pure crystals of iron 2 sulfate from the above reaction. So after we have this, we need to make sure that we dissolve it. So we dissolve it in water. So we dissolve it in water. Then after we dissolve it, then we have to warm it up a little bit. So here now, when you're warming this, make sure you just have to do it on just a minimal level. Why? We don't want all the water molecules to evaporate. We just want a small amount so that there should be some water molecules that should remain. For us to have crystals, we need water. So the reason why we are dissolving it, so that the crystals can only be formed if there is a small amount of water. So you dissolve it, then after that you need to evaporate a small amount of water. Then after that, you just leave the mixture. It will form the crystals. Then B, when an iron nail is placed in an aqueous solution of copper 2 sulfate, a reaction takes place. Then you construct an ionic equation for the reaction. So construct an ionic equation for the reaction. So it's iron, Fe, solid, plus copper 2 sulfate. So this is a single displacement reaction. Why? Iron would displace copper, giving us iron sulfate plus copper. So now, since we are dealing with the ionic equation, we'll now say we need to break. Let me see what I can do. Okay, I have enough space. So iron in solid, we'll just leave it like that. Then copper has a valence of 2, so aqueous plus sulfate minus 2, then iron plus 2, sulfate minus 2, plus copper. So what are we going to consider as our spectator ions? So sulfate is a spectator ion. So our final net equation is iron plus copper and we have this one plus copper. And remember, this is also a redox reaction. There is a reduction and oxidation, but will not go in detail for that. So state 2 observation you would make during the reaction. So the observation is the solution will change to brownish color because copper has that brownish. Also, there will be a rise in temperature, so the beaker may feel hot. Okay, so the reaction between 4.2 grams lump of magnesium carbonate and 0.1 molarity hydrochloric acid is relatively slow. The reaction can be increased by either increasing the temperature or using a catalyst. Other than increasing the temperature and using a catalyst, state N2 other conditions that can be applied to the reactant in order to increase. So these are the factors that causes or that may make the reaction to be fast, of which we have been given the first two, which is temperature and catalyst. So apart from these two, what can we do? So by increasing the concentration. So the concentration of reacting particles. So whenever the concentration is increased, the rate of a chemical reaction is fast. Then condition number 2, by using smaller sizes of reacting particles. Then explain how a catalyst would increase the rate of a chemical reaction. So by lowering the activation energy. So if we are to summarize the factors that increases or affect the rate of a chemical reaction, the first one is temperature, if you are asked. Then in the second one, pressure for gases. Apart from pressure, then by using a catalyst, then size of particles, then also nature of reactants. Like this one means group 1, we know that the nature of group 1 elements are more reactive, so you just have to look at the factors, then also how are these factors affect the rate of a chemical reaction in case you are told to explain. Then also the other thing that you can look at here is the graph. You may be given a graph plotted for you, or maybe coordinates, and you're asked to plot. Then the graph for rate of a chemical reaction will mostly be like this. So at this point, the reaction, it is at its fastest. Then here we have fast. Here starts to slow down. Then here where it is parallel to the x-axis, this is where the reaction has stopped. Then if you want to look at, if let's say if we are dealing with volume in the y-axis and asked to find the final volume, the maximum volume that was produced, you just have to look at the height in the y-axis corresponding to the line where the graph reached. So the number at this point, if this is 40, then the maximum is 40. Then if this is where the line started to move parallel to the x-axis, so this is the time of completion. That's what you do. So you need to look at how to plot this graph, then also interpretation, where the reaction is fast, slow, then the reaction comes to a stop. Then you have question B. Nitrogen and hydrogen react under suitable conditions to produce ammonia following the reaction. So give the numerical values of A. So this is the Haber process. So A, let's look at B. We know that B will be 2. So we need to put 2 here. Then 2 times N, we have 2N. Then 2 times 3 here, we have 6. So we need to put 3 here. So A is 3. Apart from the temperature and catalyst, mention one other factor that can increase the rate of the production of ammonia in the Haber process. So apart from temperature and catalyst, so we need pressure. So the 3 factors that we give that affects the Haber process or conditions, remember it's the pressure, then the temperature, also catalyst. So group 8 elements of the periodic table are also called group 0. Explain why group 8 elements of the periodic table are referred to as group 0. So because they have a valency of 0. Then if it comes to reactivity, these are electrically stable. So what common name is given to group 0 elements of the periodic table? So we have noble gases. Noble gases or inert gases. Then give a group 0 elements of the periodic table have practical use in everyday life. Give one use of argon. So in bulbs. Then neon in advertising. Science. Okay, so the diagram below illustrates the laboratory preparation of ammonia. So this is by heat decomposition of ammonium chloride and calcium hydroxide, where we are going to have the product of calcium chloride plus water and ammonia. Now let's look at question A. So question A, construct a balanced chemical equation for the reaction being illustrated in the diagram above. So the reaction is, we need to have ammonium chloride, which is in aqueous, then react with calcium hydroxide. So hydroxide has a valence of 1, calcium has a valence of 2. So the hydroxide will be enclosed in brackets, also aqueous. Then we are saying the product will be calcium chloride aqueous plus water plus ammonia NH3, which is a gas. Now let's balance this equation. So where do you think can we put the numbers? So we are going to put 2 in front of ammonium so that we have 2Cl because of 2 here. There is a 2 here. Let me first. Then hydrogen we becomes 2 times 4 is 8 plus 2 from the calcium hydroxide, which is in total we have 10. So how can we make 10 on the other side? So let's put 2 here so that we have 2 nitrogen 6. Then we also have to put another 2 here so that we have 4 hydrogen plus 6, we have 10. So our equation, you can see that is now balanced. Then B1, set the common name of substance X. So substance X is calcium oxide. That is, this is not the common name, this is the chemical name, but the common name is this is slacked lime. Then what is the purpose of substance X? To dry the ammonia. So we can see that among the products we have water. So how can we remove water? So we can use calcium oxide, so to dry this. Then why is ammonia collected by using the method shown above, which is upward displacement of air? So because not water, so because ammonia is soluble in water, so we cannot use water, it will dissolve. Then describe the chemical test for ammonia gas. So say it turns damp litmus paper. Blue. Then give 2 uses of ammonia to make nitric acid, then also to make fertilizers. So question A, name the elements in group 5 which is in the same period as sodium. So here you just have to answer using a periodic table, or we are looking at the periodic table and its trends. So we can look at sodium. We know that sodium has the atomic number of 11, which is 2,8,1. So it has 3 shells. So we need another element from group 5, which is in group in period number 3. So period number 3, what is that period number 3? So that is phosphorus. So phosphorus, where we have here 15, then here we have 31, because if you write the configuration, it will give you 2, 8, 5. So you can say that these have the same number of shells. Set the number of protons and neutrons in one atom of the element named A above. So protons is just 15. So you just get this number here. Then neutrons will be 31 minus 15. This will give us 16. So the neutrons is just the difference between the mass number and the atomic number. Write the electronic configuration of the element named in A. We've written, but let's do this once more. So how do we write the electronic configuration? So you look at the number 15. So first shell we know will occupy 2. So 15 minus 2 we have 13. Second shell will occupy 8. So 8 plus 2 we have 10 in total. 15 minus 10 we have 5. So the outermost shell will have 5. Explain why the named element is placed in group 5. So because it has 5 electrons in its outermost shell. So to summarize the periodic table, we have 8 groups on the periodic table. Then to know the group where the element is found, just count the number of electrons in the outermost shell. So group 1 has 1, 2, 2, 3 up to 8. Then period has to do with the number of shells. So groups are considered to be vertical. Then periods are considered to be horizontal. So that's a pattern. Then the other thing that you can look at here is the other name for group 1 elements, which are known as the alkaline. So we have the alkaline. Then group 2 have the alkaline earth metals. Then what else? You can also look at which group of the periodic table are the most reactive. So the group 1 are the most reactive elements. Then if you look at the non-metal, the most reactive in terms of the non-metal are group 7. And the group 7 are also known as the halogens. So you just have to look at that. So halogens. So that is what you can look at. Then also uses of maybe transition. Oh, and I made a mistake. Group 1 are not known as alkaline, but alkali metals. So alkali is for group 1, then alkaline for group 2, halogens group 7, chalcogens group 7, 8 chalcogens group 6, then 7 halogens, 8 we have noble gases, inert, okay, things like that. Okay, so now iron is extracted from its ore in a blast furnace. So we have the extraction of iron. So you need to look at the ores for iron. Then this is the diagram for a blast furnace. Then coke and materials X and Y are fed into the furnace. Name the materials X and Y. So what's our X? Then what's our Y? So let's go back to our diagram. So we have coke. Coke is also known as the carbon. So apart from coke, we need limestone, which has a chemical name of calcium carbonate. Then also the hematite, which is iron 3 oxide. And these three are collectively known as a charge. So X can be limestone or hematite, doesn't matter which one is the first. Then what is the use of the waste gases? So the waste gases are gases like carbon dioxide. So we know that the surrounding air, these gases like oxygen, must be heated up before entering the blast furnace. So the waste gas that is coming is so hot. So the importance of this is to heat the surrounding gases. So say to heat the surrounding gases, which is oxygen. So we know that we want oxygen, the one that is entering, to be hot. So that is the use of the waste gases. So as the waste gases the waste gas is escaping into the atmosphere, it has to heat the oxygen before entering the blast furnace. Then C1, what is the reducing agent in this extraction? So whenever you're looking at the extraction of iron on a blast furnace, the reducing agent is just carbon monoxide. Then describe how the reducing agent is produced. So by reacting carbon dioxide with excess carbon. Then what else are we looking at here? What is the purpose of each of the following? So the first one, hot air. So what is the purpose of hot air? So say to react with carbon to form carbon dioxide. So this is stage 1, where the carbon react with oxygen to form carbon dioxide. Then stage 2 is now where coke, which is the coke, to react with carbon dioxide to form carbon monoxide, which is a reducing agent. Then show the balance equation. Show the balance equation in which iron is extracted. So among the 5 equations, so we're just interested in the third one. So we have iron 2 here, 3 here, solid, plus carbon monoxide, which is a gas. It will give us iron solid plus carbon dioxide, which is 2 here. So we just put 2 here. Then we can put 3 here, 3 carbon, 3 carbon. So 3 carbon, 3 carbon, 3 here, 3 oxygens, also 3, 6. So our equation is now balanced. The other thing that you can look at here is uses of iron, then maybe the alloys that iron can form. So the alloys that iron can form, the first one is steel. Now in steel there is iron / carbon. Then we have another one where iron is. So we also have like stainless steel. Sometimes you may encounter a question like give 2 examples of alloys where iron is found. So you have to look at the uses of iron, how iron is extracted, from which furnace is extracted. At least if you look into those areas, you may find this topic to be useful. So we have another question. Generally, some metals easily corrode when exposed to certain conditions. Explain what is meant by corrosion. So we'll say this is the chemical wearing of a metal. Then, which of the metals, zinc, potassium, or copper, corrode fastest when exposed to certain conditions? So whenever you are looking at the metal that does the fastest corrosion, you just have to look at the one which is the most reactive. So according to our list, potassium is the most reactive. Hence, it will corrode faster than the other two. Give two conditions that easily promote corrosion. So the first one, atmospheric oxygen. Then we can say moisture. So if you look at moisture, it's same as just water. So for rust to occur, these two must be there. Then give two methods of preventing corrosion of metals. So the first one, we can say by oiling, then by painting, by greasing, then by galvanizing. Okay, so we have another question where we are looking at the allotropes. So the following diagrams show two forms of carbon P and Q. Name the allotrope labeled P. So P is the diamond. So you just have to find ways of how you can recall the structure. So you need to look at how can you, so diamond has this kind of the arrangement. But whenever you have this layer and another one on top, like this one, where you, so this is a graphite. Maybe for me, what helps me to remember, or what helped me to remember this is letter G. I just have to look at letter G. I have this, so I consider this to be as a layer on top and this also to be a layer below. So I have this graphite, but you can look at what works for you. If you are okay with mastering this, then that's okay. So Q is graphite. Explain the meaning of the term allotropes. These are different structural forms of the same element that exist in the same physical state. What type of bonding is represented by these forms of carbon? So the two have covalent bonding. B1, which allotrope named in has a physical property which is typical of metals? So it's graphite, like conducting of electricity. Graphite does this. State the physical property. So here we can say it conducts electricity. So what else can you look at here? You can look at the uses of graphite, so you may also revise on it, how this is used. So it conducts electricity in terms of graphite. It can be used in to make lubricant since it is soft and greasy. Then you also have to look at the uses of diamond. Okay, so in the periodic table, elements are arranged in vertical columns called groups. Potassium and sodium are both found in group 1 of the periodic table. Give the electronic configuration of both elements. So let's begin with potassium. Okay, so has the mass number of 39, then the atomic number of 19. So the configuration, the first one will occupy 2 electrons. So 19 minus 2, we have 17. The second one, 8. Then 10, so plus 8. Then 1. Then let's look at sodium, 23, 11. So the first shell, 2, 8, 1. So you can see that the number of electrons in the outermost shell is equal to, they have the same number, thus they belong to the same group. So we've answered 1, 2, which element would react more vigorously with water than the other. So here we want between potassium and sodium, which one is more reactive. So potassium is more reactive, so potassium would react faster because potassium is below sodium, and as you go down the group, their reactivity increases. So according to period to group 1 trend, whenever you go down, so the one that is below is more reactive than the one that is above. Then write a balanced chemical equation for the reaction of sodium with water. So sodium is a metal solid plus water, H2O liquid. So we are going to have sodium hydroxide. We have aqueous plus hydrogen. So whenever you use a pure metal, you get hydrogen as a gas. So we can put 2 here, 2 here, then 2 here. Then we have our equation is now balanced. Then in group 7, there are 5 elements. How many electrons do these elements have in the outermost shell? So since they are in group 7, they both have 7 electrons, because the number of electrons in the outermost shell is used to determine the group. Then how do the atoms of group 7 elements react with the atoms of metals? So say how? Very. So they are very reactive. The group 7 are the most reactive non-metals. So very reactive, then we'll say by gaining electrons. Then which of the group 7 elements is the most reactive? So the most reactive is fluorine, because it is above the other halogens. And we know that for group 7, if you go up, the reactivity increases. Then for group 1, you go down, increases. So that is the pattern. Okay, so we have another question. Table B4 contains atomic mass units, AMU, and percentage abundance for element Q. Then the question is determine the relative atomic mass of element Q. So how do we find this? So say relative atomic mass is equal to, so we have the first row, the percentage is 52, so you get the percentage over 100, so that's what you do. So it's a percentage which is the abundance over 100 times the AMU, which is multiplied by 107, plus you do the same. So here the abundance is 48 over 100 times AMU, which is 109. So that's what you do. So let me first get my calculator. So okay, so according to my calculator, 52 divided by 100, I'm getting 0.52 times 107, plus here we will have 0.48 times 109. So let's now find it. So 0.52 times 107, we get 55.64 plus 0.48 times 109. So we get 52.32. Then the sum of these two numbers is the number that we are looking for. So I'm getting 107.96 as our final answer. Then what else are we supposed to do? Describe a radioisotope. So a radioisotope, how can you describe a radioisotope? So a radioisotope is just defined as atoms with the same proton number but different nucleon number. So we can say atoms of the same elements. With the same atomic number but different number of, different mass numbers. And let's look at this one. State one use of carbon-14 isotope. So in a radiocarbon dating. So this is just the process by which the life of a dead substance can be determined. Then iodine 131 to treat goiter. So the following reaction scheme shows what occurs during the extraction of zinc metal from one of its ore zinc blend. So deduce the chemical formula of zinc blend. So the chemical formula is this. So zinc sulfide. Then if the question is what is the chemical name for zinc blend, you just have to say zinc sulfide. Then name the solid L and gas M. Solid L. So the first one, the zinc blend is roasted in air. So when the zinc blend is roasted in air, which is the oxygen, it is going to give us zinc oxide plus sulfur dioxide. So here we are going to have zinc oxide. So L is zinc oxide. Then gas M. So what happens now if you burn solid, zinc oxide in coke, so it is like this. So zinc oxide plus carbon will give us zinc plus carbon monoxide. So the gas is carbon monoxide. So remember, the gas that is produced during the extraction of zinc is carbon monoxide, not carbon dioxide. Then construct the chemical equation for the reaction of solid L with coke. So zinc oxide plus coke, we get zinc plus carbon monoxide. So it is a balanced chemical equation. Sulfur dioxide gas is a pollutant, so explain its effect on plants. So it causes the acidic rain which later destroys plants. Okay, so now we can look at the last question. Nitrogen is used to manufacture ammonia as shown in the diagram. Okay, then name the process shown above. So this is the Haber process. So Haber processing is just the process that is used to produce ammonia on a large scale. State the substance represented by X. So apart from nitrogen, which one is the raw material? So is hydrogen. So the hydrogen will react with nitrogen under certain conditions to give us ammonia. Write the condition represented by Y and Z needed for the process. So what's our Y? So Y, we can say that we have degrees Celsius is just temperature, or you can just know that the temperature is part of the condition. Then Z, because of ATM, is pressure. Name the catalyst used, so we'll say iron. So iron is the catalyst used in the Haber process. That's why the other use of iron, you can just say used as a catalyst during the Haber process. Write the main ore from which the catalyst named in D1 extracted, so hematite. Construct a balanced chemical equation for the reaction shown in the diagram, including state symbols. So we have nitrogen, which is the atomic key, plus hydrogen, giving us ammonia. So we need a 2 here, so that 2 nitrogen, 2 times 2, 3, 6, so we need a 3 here. State one use of ammonia to make fertilizers. Then the other thing that you can at least look at, you can look at the type of oxides. So types of oxides will give you the first one. We have the basic oxide, where we have metal oxides, then acidic oxide like sulfur dioxide, then we have neutral oxide like carbon monoxide, then also amphoteric oxide, which is which act as a base and also as an acid, and also examples of amphoteric oxide, you can start of those. Then also some identification. So that's it for this video. Thanks for watching.